All right. Happy Monday. I think it's Monday. I don't know.
Yeah.
I think so. I was just confirming here. So for the prereqs, there's actually no statistics for your prereqs. And so what we're going to cover today might feel a little bit like a lot, and it is if you haven't done any stats before. So if you do find that you have any questions, then let me know. I posted summary notes that I put together. It's a bit longer than the chapter 1 summary notes. But basically, again, everything that I want to talk about are here in the summary notes, and these are kind of the core concepts. I tried to keep them as brief as possible, but then there are some topics that are going to require a little bit more, right? And so we'll work through these notes this week. So it's not all today, it's for, this week. I suspect we might need to head into next week as well. We'll see where we're at, but I'm okay with that because it is kind of the groundwork of everything. And so I want to take our time a little bit through chapter 2. And so if you've done some sort of intro stats before, then it'll kind of feel a little bit familiar. If you haven't, it might feel a little bit scary, but we're not going to do any calculations by hand if that makes you feel better. So bless you. That's what you get when you have your camera on. I can see you when you sneeze, so you get a
yeah. I got to remember that people can see me, so I shouldn't like pick my nose or something.
Yeah. If you've got your camera on, I'm looking at you and it's way more fun. Okay, so before I forget, a little reminder, I saw most of you have submitted the markdown files, so good. But if you haven't, it's due at midnight tonight. So just a reminder, markdown. I shouldn't say markdown file because that's a separate file, so that might get confusing. Markdown test due tonight at 11:59. So make sure you get that in. Okay, so let's see here. Should we dive straight into it, or was there something that I was thinking of that I wanted to bring up? Any outstanding business from last week? I don't think so. Can't think of anything. Didn't write anything down. So it's in one ear, out the other. All right. So, like I said, I just posted the chapter 2 summary notes like half an hour ago. Not cool, right? I kept going back and forth and changing them until finally I had to say, no, let's just commit and we'll use these ones. But I think they're pretty good. I mean, it's what I'm going to be using. So I even used the fancy chapter 2. Okay. Uh-oh. It's been doing this. It's been lagging like crazy. My little iPad. I think it needs a restart. But not now. Okay. So just like last day, my handwriting is not that good, but also I'm really slow at writing. And so I find that if I have the typed up notes, and what I used to do is I would just basically type up the textbook again. I don't really see the point of doing that anymore. So now I just steal from the textbook and hope that no one tells on me. So this is just straight from the textbook, but that's, I don't know, it's just how I do it. So just like last day, I'll grab the points in that I want to talk about, probably write a little bit around them, not a whole ton depending on the topic, and then I'll post these notes afterwards on Moodle, right? So you'll have kind of two sets of the same notes, one filled in class. Okay, so first thing we have to talk about is just how do we talk about data? Now, again, if you haven't taken a stats course, right, data is just what we're going to be analyzing, right? So data might look something like this. So I'm going to bring in this huge table. Okay. So data might look something like this. And this is for the Dow Jones Industrial Index. It's a common index for how are stocks in general behaving, right? And so what they've done is they've taken a sample of different companies, right? And they've looked at their share price and their volume, right? Which are all going to contribute to just how the stocks are behaving, right? And so this here is what we would imagine a data set to look like, right? Typically, we're storing them in some sort of a spreadsheet, right? And so Excel is a really common one that I hope you have used at some point, maybe cursed at some point, because Excel has a little bit of a learning curve, right? And so, but if you just imagine an Excel spreadsheet, then you're going to have, let's see if I can change the color here, right? Then you're going to have observations here as your rows, right? So there's an observation for Apple, right? And we're looking at and we're collecting, or they've collected all this information for Apple, and then same thing for American Express, right? And so we call these our observations, which are the rows, right? And then we've got these columns, things like the symbol, the industry, the share price, and the volume. If you think about analyses, right, analyzing the symbol, which is unique to each company, isn't going to give you much information, but it's information that we have, so why not just include it? And because it changes for each row, right, for each observation, then we call it a variable, right? Some variables are kind of more interesting than others. For example, industry variable might be more interesting than this. Everything's more interesting than symbol, right? There's only one of each, so that's boring, right? Usually we'll be interested in the share price or even the volume, right? Depending on the question that we want to answer. But what we say is that these columns are variables. Which are the columns. Okay. So when we talk about data, typically in general, right, we mean this whole spreadsheet, but we're usually talking about how are these different variables behaving, okay? So every problem, right, is looking at how does a variable vary, right? How does a variable change? So how does the share price, for example, change depending on which company it is, right? And so, so the variation is what we're going to be analyzing typically, right? We're going to look at other things too, the average, among other things, right? But it all comes down to the variation. Okay. So, good. That's just some kind of basic terminology, right? Observations and variables. And I always kind of had a hard time. So variables, we throw that word around. But if you just think of it as just the column in your spreadsheet, then it'll click a little bit faster, I find. Okay. So these variables, hey, I should have done a restart on this thing. Not even sure I know how to restart an iPad. So thank you for asking that, because I was thinking about the same thing. So company, I wouldn't be mad if you called it a variable. It's really just the variable for the observations. So I've excluded it in my variables here, right? I started at the symbol, but technically we could have another row, or sorry, another column with numbers where we number each company, and then the company would be a variable. But because it's unique, so because this is kind of the name of each observation, the textbook is saying that it's not a variable. But I was thinking the same thing. So good for you for kind of, so what's going on here? Yeah, so kind of vague. Yes and no. Company is not a variable, can be
I guess
a
it just
variable.
depends on what you're looking for, right? Like,
Totally.
just, you know, they just want like an industry perspective.
Mm-hmm. Totally. Yeah. So it's going to come down to what are you interested in? What's your research question? But in this case, they're defining the company as just the name of the observations. So no, but I would argue yes. Keep you on your toes. All right. Good question. How can I get this to fit on one page but still be readable? I don't know. You can see why it took me so long to land on these notes, like resizing.
Make it, you know, make it just a little bit.
How about that?
Yeah, that's good.
Okay, so good. Okay, so maybe that's what I'll do, because then when I save the notes, they're not like huge. You know, when you print slides from courses and they're just like massive, seems pointless, but we have to be able to read them. Okay, so in statistics specifically, which is basically any analysis, it's going to be really important that we keep track of the population that we're interested in versus a sample from that population. Okay, and so I guess I should be doing this, right? Because a sample is a subset of the population. So the population is just all things that we're interested in. So usually we have to narrow down, you know, we're interested in females between the ages of 18 and 25 in Kelowna, right? That's a really specific population. But depending on the question that we're trying to answer, maybe that's perfectly reasonable, right? And so maybe that is the population that we're interested in, right? We're opening a new lawn downtown or something. I don't know. It's a fun store. But anyways, so the population is just all things that satisfy some certain criteria. And then the sample, oh, sorry. Did you have a question? No.
Are you talking to me?
No, I thought Bridget had a question.
No, no, no.
No. No. Okay. So for us, all our analyses are going to be from a sample. So we collect sample information and we're trying to learn about the population. And that's basically any analyses that we're going to do, especially in this course, right? We're going to collect a sample and look at sample information to try to learn about the population. Now here, I want to write that down, but I don't want to write it on lines like this big. So I'm going to zoom out again. Well, I probably should. I guess I should say in statistics, which is basically any analyses, analyses, I can never keep them straight. We use sample information to learn about the population. Okay. So I'll keep it zoomed out for just a second more here. Whoop. What gets confusing a lot of the time in statistics especially is that then we have things like the sample mean, but also the population mean, right? And the mean is the average. Well, spoiler alert, right? We're gonna get there. But the mean is the average. And so we're going to have sample information, and then we're trying to learn about the same thing, but in the population, which just intuitively, we understand that if we look at the average share price of these 30 stocks, right? That's not exactly the same as the average for all stocks, right? The population of every single stock out there. But it should be pretty similar, right? And so, and that's where it gets a little bit tricky, but that's where statistics come in and help us kind of figure out, okay, based off of the sample average, what is a reasonable range for my population average, for example. So I know, this isn't a statistics course. Well, it isn't, right? We can't do any sort of business analytics without stats. Bummer, right? But instead of the traditional approach where I make you do things and calculations by hand and just boring and rude, I'm gonna make sure that you know how to do these calculations just in Excel or in R and potentially both. Okay? So kind of easy street. In general, right? If you want your sample to be representative of the population, which you do, right? If you're trying to use it to say something about the population, it has to be representative of the population you're talking about, right? And so usually random sampling or some version of random sampling is good enough to get you that representative sample. Okay, so I'm going to highlight that here because it's really important. in terms of the Dow, so this sample of 30 companies, oh, it's lagging, sorry. Hello, there. So this sample of 30 companies is actually not randomly selected. So the idea with the Dow, I guess, this isn't my area of expertise, but from what I've read, the Dow was formulated to be as representative of all the stocks that are available at some moment in time, right? And so they cherry pick their companies that are going to be in this group. And I think it said they started in the 1800s. So obviously Apple and American Express are new additions. And so that's what they do. They're constantly updating this index. So it's not always the same companies that are in there. They're kind of changing over time. And so obviously there's a whole crew of people working on that as well, right? Which companies should be in the Dow, right? Maybe there comes a time where, no, all these are huge. I can't decide which one to cut, but maybe United Technologies. I'm sure they're huge. I've never heard of them, but maybe they just kind of go bankrupt or something weird, and then they have to be removed and then get replaced by something else. So in this case, this is not a random sample, right? It's a very specific sample. But in general, if you're trying to learn about a population, then you should have a representative sample, right? And how you get that is through random sampling. And there are lots of different sampling techniques. That's not for this course, right? But if you do find yourself having to sample something, you might want to hire someone if you aren't sure of how to do it, right? Because it's really important, right? Everything hinges on your sample being representative of your population. Okay. Good. Oh yeah, while I'm here, I have to clean up these Excel practice things. So what the textbook does is it's merged information with how to do it. And it's nice if you're sitting down and you're reading the entire textbook, which maybe you're skimming it. Right, but what I wanted to do is I wanted to extract all the Excel information so that you can access it separately. So it might mean that you have to kind of match things up, but I do have to clean it up before I post it for you guys, but it's coming. Okay. It does assume that you're sort of comfortable with Excel, but not terribly. Why did I say that? Oh, just because I was showing it on my screen. That's why. So in terms of, how about that? In terms of our variables, we can classify our variables as either, and this textbook uses the terms quantitative and categorical, which is a weird mashup. Usually we say numerical or categorical or quantitative and qualitative. But in general, I like to develop this kind of tree, right? So if we have a variable, start over. It's not better, but I'm committing. Okay, so a variable can be split into two categories. So there are really only two things that a variable can be. And then, of course, after that, we can split it up even further. But for us, We just need to be able to distinguish between a quantitative variable or a categorical variable. I'm trying to use the terminology that the textbook uses, but a variable can either be quantitative, right? If you think quantity, right, or numerical, oops. I usually like numerical just because it highlights that it should be some sort of number, right? It should be a number variable, yeah, a number variable or a numerical variable. Whereas categorical is any variable that can be split into distinct categories, right? And so I'll do my kind of, this is how you, or how I remember it, category. Or can also be called qualitative. Qualitative. These are hard to spell, right? And so qualitative data, usually we link them like this, and this is why I'm so kind of thrown off, quantitative and qualitative, or numerical and categorical, but they've decided to go for quantitative and categorical. Oops. So doesn't matter, as long as you're aware of all these definitions, and that whenever you see quantitative, it's the same as numerical. I might slip up and I might use the term numerical. And if you see categorical, it's the same as qualitative, right? So just be aware of those. But categorical data is any data that can be placed into distinct categories. Whereas a quantitative variable or quantitative data is any data that can, or any data that's a measurement. Okay. Any data that is a measurement. Okay. So typically things like speed, distance, money, right? Speed, distance, money, right? Things like that, those would be numerical variables. So we're going to look at the variables from the Dow index. And I'm just going to use what's called the kind of the head of the data. So I'm not going to bring in the entire thing. We're just going to look at a snapshot of the top. I don't know what I picked, 5 maybe. Okay. So here, let's assume that the company is not a variable, right? So let's ignore the company variable, although this is one of those cases where if you wanted to argue that company is a variable, I'm open to it. If you want to say, no, it's not a variable because it's the observations, I'm open to that too. You just have to have logical reasons to back up what you're saying, right? And so, and it has to make sense. You can't just make stuff up. But if you have kind of something to back up your reasoning, then I'm on board with it most of the time. Okay, so we're going to focus on symbol, although it's kind of boring, the industry variable, the share price variable, and the volume. Now, what I want you to do is just think about what type of variable is it, right? Is it a quantitative variable or is it a categorical variable? The reason it's so important to be able to identify if you have a quantitative variable or a categorical variable is because depending on the type of variable you have, that's going to determine how should you summarize this data, how should you analyze this data, right? And it's going to send you on two very, very different paths, right? And so in order to kind of put together kind of a reasonable analysis, right? Step number one is identify what type of variables do I have, right? And then that's going to tell you what to do next. So if we were analyzing the symbol variable, like I said, kind of boring, but that's okay. These are not numbers, right? So right off the bat, that's a clue to me that this is going to be a categorical variable, right? There's only one thing in each category. That's what makes it so boring, but it's still a categorical variable, right? So here, symbol is categorical. Oops. Industry. Now each company is being classified as either technology, financial, manufacturing technology, right? So now we're seeing more in each category, right? More observations in each category. So that's a little bit more interesting, right? We've got technology, financial, manufacturing, and then we know there's more because the data set is larger, right? But we're just looking at these here. And so industry is also a categorical variable. What we'll see, right, is that categorical variables are kind of boring in terms of analyses, right? We could say, oh, there are 4 companies in the technology industry. There are 13 in the financial industry. There's 4 in the manufacturing. Why do I go for 4 every time? I don't know. 7 in the manufacturing industry, right? Kind of boring information. It's information, right? And it is something that you'd want to include, but it's not really groundbreaking, right? And so for categorical data on its own, we're basically going to end up reporting how many companies are in each industry. I was going to say category, but that makes it confusing. Right, so how many companies are in each industry, and that's basically where it ends, right? Once we start looking at 2 variables, right? So analyzing a combination. Sorry, did you have a question, Bridget?
No, I just.
No. So once we start analyzing 2 variables, right, then it might be more interesting to look at, okay, what's the average share price for each of these groups, right? Then we can break them up into groups, and that's going to give us more insights, right? So that's why we have these categorical variables. But where we're going to start is we're just going to look at one categorical variable and report how many are in each group. Boring. We'll start there, but that's what we're doing. Okay. For most analyses, we're going to be looking at numerical variables, right? Things like the share price, the volume, right? Both of these are numbers, right? But they're also things that we can talk about the average of. And so for me, that's a good check-in point. Does it make sense to talk about the average share price? Yes, it does. The average volume? Yes, it does, right? And so that's my gatekeeper for whether I have a numerical variable, sorry, a quantitative variable. They mean the same thing, but I'm trying to use the terminology that the textbook uses. So these are both numerical. Oh my gosh, I did it again. I'll be better, I promise. Quantitative. I'm going to cheat so I don't have to write it again. Quantitative. It's hard. Okay. So, right, as kind of a check-in point, like I said, if it makes sense, to talk about the average of a variable, it is a quantitative variable. It is a quantitative variable. Ha. Okay. So that's just a guideline that I use often, right? Does it make sense to talk about the average? If it does, sometimes there are cases where you're kind of like, sort of, but not really. If you're finding yourself saying not really, then you can probably make it categorical. Okay. For example, a categorical variable that would be a number, right? So categorical variables can be numbers. If I ask you what year you're in, first year, second year, third year, fourth year, fifth year, victory lap, I don't know. You guys are in a 2-year program though, I think. But let's say just undergrad, you know, first year, second year, third year, you know, those guys. Those are numbers, but because a student would say, oh, I'm in first year, right? They're placing themselves in that category, then we would treat it as a categorical variable. You could, again, the power of persuasion here, you could argue that it's a numerical variable by saying, oh, I can talk about the average year of students at the college, so it is a quantitative variable. But for the most part, I would say that it's a categorical variable. And that's what makes it hard, right? Is that sometimes you can argue one way or another, and other times, no, it's categorical. No, it's quantitative, right? So that's going to take some practice. But for the most part, it'll be kind of obvious for what we're going to be doing. Okay. We're mostly going to be dealing with money, and that's quantitative. All right. Okay, good. Business is usually kind of the main user of cross-sectional and time series data. Cross-sectional data is where you've got a snapshot of something in time, right? So for example, this data here, right? Consider the whole data set, even though I didn't paste it all in, right? This is a snapshot of the share price of each company at some moment in time. And we all understand that that's going to change for each moment in time, right? But when we have this snapshot of, okay, at this time, the share price for Apple was $195, the share price for American Express was $123, right? This is what we call a cross-sectional data set. Okay. So it's just looking at a cross section. What's what's happening at one point in time versus time series data. Time series data is going to be looking at how are things behaving over time, right? And so there's a difference there where time is one of the variables, right? And so we could add another column here where it's time, right? And maybe we have the first quarter, second quarter, third quarter, fourth quarter data, right? Or maybe we have it by day, right? Then each of these companies would be repeated on each day, right? And it would probably be the average. I'll leave that because it's getting into some nitty-gritty stuff, but right, you might have some summary number to report for each day or quarter or whatever, right? And so time series data, right, are frequently found in business and economic publications. Those are data that look like this. Let me bring it in here. Right, something like this, where we're looking at how does the overall Dow Jones Index average values since 2006. So how does this Dow behave over time? Right, so notice here that because we have time on the x-axis, and in case you need a little refresher, this is the x-axis and this is the y-axis. Okay. However you need to remember that is fine by me, but you do need to remember that that's the x-axis and the one that's pointing up is the y-axis. And I just kind of remember it. I don't know where you guys are at with your graphs. Maybe it's been a while, but I did have one student a long time ago tell me, oh, yeah, I can't remember those for the life of me. But what I do remember is, so if you imagine the x-axis is up along the y-axis, and then she was imagining like a little guy down here going, no, because it was falling on him. So then she's like, that's the x-axis because it's fallen. So it's like, boop. Anyways, whatever you got to do to remember which is which, you just got to do it. Okay. So time here is on the x-axis, and that's what makes it time series. So this is a time series graph, I guess. We're going to look more into time series, right? But what happens is the index from the year before is a little bit dependent on the previous year, right? So there's this kind of backwards link of, well, if it was kind of increasing in the previous year, it's supposed to be increasing in the next year and in the next year and the next year. And then we had a little bit of a crash, well, not a huge crash, right? But things have been steadily increasing since then. We had a minor crash around here, it looks like, or at least a plateau, right? And then things got really volatile just before 2019, it looks like. Okay. So, right, but the graph itself is pretty easy to read. It's very telling, right? And we use it to look at the trends, right? And so time series analysis is going to help us analyze those trends, right? How can we kind of wrap our heads around this? Okay. I'll highlight it's already highlighted as the definitions, but they are the most important things from these little blurbs here. And like I said, we're going to get more into time series analysis later, but now at least we know what it is, right? So it's not so scary, but it's just a special case where time series or time is on the x-axis. Now time, it doesn't have to be in years, right? It can be in minutes, days, quarters, whatever, right? And so time in general. Okay. Now, as analysts, we need data, right? We don't always want to be collecting data because it's really expensive, among other things, and hard and expensive. I'll say expensive again. Right? And so there are sources of data that we can consider. Okay. Now, depending on where the data came from, there are kind of certain things that we can and cannot say. For example, we might be familiar with an experiment, right? An experimental study is where we control many, if not all, the factors that might be involved in changing some variable that we're interested in. That variable that we're interested in is called the response variable. Okay, so I'll put it here. So later, there's going to be some variable of interest, and it depends on the question, right? The question that we're trying to answer. The variable of interest might be the volume of the stocks, right? Could be the volume, it could be the share price, but it's one of those two in this case. Looking at the industry is kind of, it'll help us explain the share price and the volume, but it's going to be either the share price or the volume that we're interested in, right? And so the variable that we're interested in, we're going to call it the response variable. Okay. So in an experimental study, right, you have to first identify which variable are you interested in, right? And then you control many, if not most, of the variables. Oops. Experiments control many or all variables that might have an effect on the response variable. Effect on the response variable. Okay. I could go on, but the main thing about experimental studies or experiments is that that's the only way that we could establish causation, right? A change in this variable causes a change in the response variable. So on the flip side of that, unless you have an experiment, and especially in business, you rarely have experiments. You don't get to do experiments. You don't get to control things. Then you have a non-experimental or rather an observational study. Okay, so an observational study you're just observing. So you're making no attempt of controlling any of the variables. You're just observing what's happening, whether you're observing it from the past or currently. Hard to observe it for the future, right? That's something else. But observational studies are what we will most likely have, which means that we can't say that this causes a change in the response variable, right? But I will highlight that more later. Okay? But for now, a survey is definitely the most common type of observational study. That's the most common way that we collect observational data. Okay? So you identify your research question, and then you design your questionnaire to be able to answer that research question. A lot of the time, studies have already been conducted, whether it's an experiment or an observational study, this data already exists. So in that case, you could just use that, right? If it's available to you, sometimes you might have to pay for data. You won't, right? Just we in general might have to pay for data, right? If it's collected by some company, right? But what we're dealing with right now in terms of business analytics is businesses have collected all this data. So they got caught up in this frenzy and they have all this data and they've stored so much data on their customers, on their employees, on their everything they could get a hold on, they've collected, but now they need someone to analyze it, right? And so that's where we're at. Okay. And so a lot of companies just have all this data. And of course, because we're just kind of going in and looking at it, nothing was controlled, that's going to be observational data, right? So this is all observational data. If it already exists. Oh, I guess it's not the first sentence, but you get it. Okay. So 2.3, we're not going to go through today, but it will be posted. On Moodle along with other Excel instructions. I'm going to see if I can incorporate them on Friday, although what we noticed last week is 50 minutes is not very long, right? For me, for you it is, for me it's not. And so we'll see. I'm going to focus on working through our problems on Friday. And then I might sprinkle some of this in, but I want you to have it as a resource so that you can go back and work through some problems in Excel, right? And you have access to Excel for free through the college, right? So if you don't have Excel, you can get it on your computer. And if you don't know how, you can ask me and I can figure out for you, or you can contact IT. So, because I don't know, it's changed. We have 360 or 365, or they both work. It's one of those two, though. It's not both. Anyways, but you do have it through the college. So if you want to work in Excel as just kind of a quick check, then that might be a good way to practice. Will be posted. I noticed I didn't finish my sentence. Will be posted on Moodle along with the other Excel instructions from the rest of the chapter. So you will have kind of Excel instructions. Okay. Oh, that was short-sighted of me. I should have brought in more. Okay. Nope. Okay. Next thing I want to talk about are distributions. Now, distributions of data, we'll start by talking about just the distribution of one variable. So we're going to look at each variable individually. So we're going to start with categorical data, and then we're going to look at how do we look at the distributions of numerical data, quantitative data. Okay. But distributions is another one of those words that throws people off, right? But the distribution is really just when we look at this data set here. Sorry, it's catching up. Okay. If we look at the distribution of the industries, right? Really all we're concerned with, how many are in the technology industry, how many are in the financial industry, how many are in the manufacturing industry, right? And so those would be the distributions of the industries, right? We'll also be able to look at the distribution of the share price, for example, even though it's numerical, so it's not quite as obvious, right? Same thing with the volume, right? We'll be looking at the distribution of the volume. Now, when we look at the distribution, it tells us a lot of information, especially when we visualize the distribution, right? So what we're working towards is visualizing the distribution. Let me scroll down here. Okay. So distributions help summarize many characteristics of a data set by describing how often certain values of a variable appear in a data set, and distributions can be created for both categorical and quantitative data. And the goal is to kind of to gauge the variation, right? How much variability in the share price is there, right? Or what is a reasonable range for the share price? So we're going to start with frequency distributions for categorical data, right? And then move into quantitative data. So frequency distribution, if you think about frequency, is just the number of times that it occurs, right? And so it's the summary of the data that shows the number or the frequency of observations in each of the several non-overlapping classes. For categorical data, that's fine, right? Because we have these distinct categories, right? And we call those bins. So if we have a look at something like this, a data set, just bringing in a freshie. Here's categorical data. Categorical data. It's just one variable, right? But it's split across 3 columns. But really what it is, it's just 50 observations, right, of soft drink purchases, right? Coca-Cola, Diet Coke, Pepsi, Diet Coke, Coca-Cola, Coca-Cola, Dr. Pepper, Diet Coke. You can make a song, right? And so here we have 50 observations. On one categorical variable. This might be a good time to highlight that a lowercase n is going to be used for notation for the sample size. Okay, so I'll put it in pink because it's important. N, so a lowercase n is the sample size. Okay. So in this case, n equals 50, right? We have 50 observations, so the sample size is 50. Okay. We're going to use this lowercase n a lot in our calculations, or at least in our formulas, right? We're not going to do them by hand, but it's important to know what it is, right? And so make a note of that, that n is the sample size. So we have a sample size of 50 observations, and they are of a categorical variable. So what you would do, right? If I asked you, hey, could you tell me what the distribution of the soft drink purchases is, right? Even if you didn't really know what I meant, right? So I'm your mean boss and I come in and I say, hey, you got to tell me the distribution of these soft drink purchases or else. Okay, I don't really know what you mean, but maybe, right? How many are buying Coca-Cola? How many Diet Coke? There's not much else we can do here, right? And that is what you would have to do, right? And so there are definitely ways to use software to do it, right? Even I find Excel is not very clever when it comes to this kind of stuff, right? Excel is kind of an all-around decent tool, but in terms of specific statistics, it's sometimes not that good. Whereas you'll find using R to do these frequency distributions, we call them, is going to be really easy. So pros and cons, but I've got the frequency distributions here. Oh, don't look. It skipped ahead, or I skipped ahead rather. I don't think I even did it. That's all right. All right. Let's do this then. I didn't do the midway one. That's all right. Before I introduce that, we'll talk about the relative frequency. So if we wanted to, right, the frequency of Coca-Cola, we could go through and we could count it. Now, I'm just going to wing it here, so I might miss one or two, but I'll zoom in so you can try it as well. So if we're just counting Coca-Cola, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We'll try that. So we found, for example, Coca-Cola, F is, did I say 19? Okay, so the frequency in the Coca-Cola bin is 19. Now, depending on our sample size, right? If we have a nice sample size that we can kind of wrap our head around, like 100, then our brains can just magically figure out what 19 is relative to 100. But if we have a sample size of something weird like 59, or even 50 in this case, is a little bit hard to do the math, right? And so what we prefer is that we talk about the relative frequency, right? Or we could even convert them to percentages. But the relative frequency is just going to be the frequency of each bin divided by the total sample size, right? So for Coca-Cola, for example, Coca-Cola, the relative frequency is 19 over 50. Now 19 over 50, I don't know, 0.38. Well, you can't see that, but that's how I got it, not in my brain. Okay. Now we can convert that, and you most likely already did, right? When you saw 0.38, your brain probably thought 38%, right? And that's totally fine. In fact, it's good, right? Because that's how we mostly work, right? Is in percentages. We talk about percentages. So I'm going to say or 38%, right? And so what happens is we can develop this relative frequency distribution, or the percent frequency, right? So here, 38%. Luckily, it's the same thing I found, right? Diet Coke, if we did the same thing, we'd find 16%, right? Or 0.16. Dr. Pepper, 0.1. Pepsi, 0.26. Sprite, 0.1. What's important, right, is that we have to have a total of 1, right? Because otherwise we're missing categories, or if we're over 1, that can't be, right? Then we have more observations than our total sample size, which can't happen, right? And so the total must be 1 if less than 1, we are missing categories. If more than 1, right, we have more observations than the total sample size, which can't be. If more than 1, we have more observations than the sample size, which can't happen. Okay. So it's going to be really important that you always just check. Does it total 1? Now it gets a little bit tricky, right? Because sometimes you'll have irrational numbers, things like 1 over 3, right? 0.3333333333333. You end up rounding, right? But you need to make sure that your total relative frequencies add to 1, right? So sometimes you'll need to make adjustments for your rounding. Okay. Oh, I guess I shouldn't cross out a whole word. How about this? If rounding, we may need, I'll say may need to make adjustments to make sure that we get a total of 1. We may need to make adjustments to ensure a total of 1. Okay. Good. Okay. Let's talk about quantitative data. We basically do the same thing with quantitative data. Remember, quantitative data, these are numbers, right? And they're potentially on a continuous scale, right? Continuous can be can mean different. Well, it can only mean one thing, but we can talk about it in different ways. For example, money always only goes to 2 decimal places, right? And so could be considered discrete, but for us, let's just assume let's just call it continuous, right? It's on this continuous number line, and so it's quantitative. I'm going to tell you how to do it, but we're not going to do it by hand. That's crazy talk. We have computers, our phones can do this now. There's no way I'm going to make you do it by hand, right? But it's good to know where things are coming from and the fact that we're doing the same thing as we did for categorical data. So when we're creating frequency distributions for quantitative data, what we do is we basically create bins, right? We create these temporary bins, right? So let's see here. I think there's a data set that I want to reference here. Okay. So here we have the year-end audit times in days. And so here's the summary. These data show the time in days required to complete year-end audits for a sample of 20 clients of Sanderson and Clifford, a small public accounting firm. Okay, so they've got this sample of how many days did it take to complete the year-end audit. So this one looked pretty easy, 12 days, 15 days, 20 days, 22 days, 33 days. That's a mumbo jumbo, right? And so what we want to do is we want to look at the distribution of how many days did it take, right? What does it look like for this, this small public accounting firm for their year-end audit times? So what we're going to do is we're going to determine the number of non-overlapping bins. Now, there's all this kind of theory behind how many bins should you have. Basically, for small data sizes, this is a data set of 20, right? 20 clients, 5 bins is good enough. If you have a huge, huge data set, you could go as far as 20 bins. That's not something that I'm going to get you to do because R just determines the bins. It just does it for you. And I just want you to stick with the default. So because someone has programmed that to be good and reasonable, so why not just stick with that? But in general, what it's doing is you have to determine how many bins do you want to have, right? And then you have to determine how wide is each bin, right? So then we have to consider what are the maximum and the minimum values. And again, it's not something that we're going to do by hand, but you could look at this and you could figure out that your minimum, I think this is your minimum, 12. It's the smallest one I can find. And I think 33 is the maximum, right? So between 12 and 33, you want to have 5 bins. So the minimum number of bins is going to be 5, okay? Usually we, so for determining the bin limits, I go out a little bit So from 12, I might go down to 10, right? So a bin from 10 to 15, 16 to 20, 21 to 25, 26, I have to be careful, to 30. And then instead of stopping at 33, I might make a bin for 31 to 35, for example, right? And then all I do is I go through and I put each observation into its bin, right? And you can kind of imagine the heights of each bin would change, right? Instead of looking at that numerically, which we're going to start doing here, it's easier if we visualize it with a histogram, but kind of stay tuned. Also, I'm running out of time, so I'm here we go. Oh, that's the wrong document. That's just going to slow me down. Here we go. Uh-oh. Okay. So we can look at the frequency distributions. Okay. So these are the bins that they've decided on. A little bit different than mine, right? They did start at 10 and went to 34, I guess. Right, a little bit outside our minimum and our maximum. You can see how it's not very dynamic because it depends on the minimum and the maximum of this data set. So it doesn't really apply to the next data set. So that's clunky. We don't like that. But luckily we don't have to do that anymore. Right, and so here, these are the bins that they determined. Right, notice that there's no overlap here. 14 hands over to 15, 19 hands over to 20, right? Notice no overlap. Okay. I had to redo an analysis one time because I had overlapping bins and it took me way too long to figure out what was going on. We don't need to do that anymore, but still, so embarrassing, right? So you want to have non-overlapping bins. Here again, we can look at the frequency, right? How many times did we see an audit time that was between 10 to 14 days? 4 times. What's the relative frequency out of 20? Well, 4 divided by 20 is 0.2 or 20%, right? So on and so forth. Finally, we get to see a histogram. Okay, so a histogram is going to be a visualization of these distributions. So a common graphical presentation of quantitative data is a histogram, right? In fact, the common graphical presentation of the distribution of quantitative data is a histogram. And so what a histogram looks like is like this. Oh. So we've got our bins, right, on a continuous scale still. So there might be bins that are empty, right? There could come a time where we have no audits that take between 25 and 29 days, but that's interesting, right? So you don't want to smush those bins together. You want to have that space and say, oh, that's weird. There were no audits that took this amount of time. And then there might be some in the 30 to 34 range, right? But this gives us an idea of the distribution of the audit times and in general of numerical or quantitative data. And I am out of time, so we'll pick up there next day. If you have any questions, let me know. Otherwise, See you on Wednesday. Stop this.
All right.
Thank you. See you.
See ya.